Okay, so you guys are working on graphing these trig functions. So I want to go to the unit circle and show you how that all kind of ties together. The radius of this circle is 1. So that means from the center out, always 1 unit. So it's 0 degrees here. This has the coordinate of x equals 1, y equals 0. Up here, which would be 90 degrees, that's a coordinate of x equals 0, y equals 1. And over here, that's at 180 degrees. That's the coordinate x equals negative 1, y equals 0. This is 270 degrees. This is the coordinate x equals 0, y equals negative 1. Then, of course, 360, 450, and ongoing. What that allows us to do is simply this. A simple graph, I'm going to put it in, this is 1 unit here. This is going to be 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So we're going to graph y equals sine of theta. Now I realize you guys are probably graphing these in radians, and we'll make that conversion in just a minute. For some reason, it's always easier for me to think in degrees. But if we're graphing the sine, remember the sine is the y value here. This is the sine. The sine of this point, this is theta. The sine of that point is this here, the y value, that height. Well, at 0 degrees, that is at 0. It's at a height of 0, the y coordinate. At 90 degrees, that's at 1. At 180 degrees, it's at 0 again. At 270, it's at negative 1, so it's down here. And at 360, it's back to 0. So that creates that sine wave.
Did you want your that whatever you're drawing on to share on the screen? If so, it's not.
So yeah, as you can see here, at 0 degrees, sine is 0. It's 0 above the x-axis. At 90 degrees, it's at a positive 1, so that's why I put the point there. At 180 degrees, it's at 0 again, so that's why there's a point here. At 270, it's at negative 1, so that's why we got the point down there. Then at 360, we're back to 0. So the sine is graphing the height above or below the x-axis. And you can see as that angle keeps wrapping around, it's just going to go through this cycle over and over again. If I were to take a long-term view of that, it just repeats that cycle. Now, if I were to graph the cosine, y equals the cosine of theta. The cosine is the horizontal distance, or the x-coordinate on the unit circle. So at 0 degrees, the cosine starts out with a value of 1. At 90 degrees, as a value of 0. At 180 degrees, it's a value of negative 1. 270 degrees, it's at a value of 0. And at 360, it's a value of positive 1 again. So same type of curve. Looks like that. So those are the basic curves. And it's because of that unit circle that they look like that. Now there are a few things that can happen to that. The first and the simplest is multiplying the sine or the cosine. What if we have y equals a times, let's do sine theta since that's the, a times the sine of theta. What that does, that a multiplying the sine, is it changes the radius of the unit circle. And I can't say unit circle anymore because it's not a unit circle anymore, because it's more than one unit. you could think of this here, y equals sine theta, as having a 1 there. It's 1 times the sine of the theta. That circle had a radius of 1. Now our circle is going to have a radius of a. So at 0 degrees, this is going to be a comma 0. At 90 degrees, this is going to be 0 comma a. At 180 degrees, this will be negative a comma 0. And down here, 0 comma negative a. So you'll notice it looks exactly the same as this up here, only wherever there's a 1, we replaced it with a, whatever that number a is. So what that does to my graph the 90, 180, 270, and 360. Instead of going up to 1 and down to negative 1, this goes up to a and down to negative a. And at 0 degrees, if we're talking about the sine, remember sine is the height above or below the x-axis. It starts out at 0. I'll do it in green so it matches up. And at 90 degrees, it's a units above. 180, it's at 0. 270, it's negative a, so a units below the axis. And at 360, it's back at a height of 0. This is one of the ways I remember this, is I tie things together. Sine, when we're dealing with vectors, gives us the vertical dimension. Or the y component of the vector. Sine of whatever its reference angle is. So it's the same thing here. The sine is describing whatever point we are in the unit circle. It's describing that vertical distance above the axis. Cosine then is going to be exactly the same way. If I have y equals a cosine of theta, well then here at 0 degrees, that's at a 0. Well, cosine is measuring the horizontal, so it starts out at a. At 90 degrees, horizontally it's 0, so it's 0. At 180 degrees, horizontally it's at negative a. At 270, horizontally it's at 0. And at 360, it's back out to a positive a. So that number multiplying in front of the trig function, all that does is changes the radius of that circle. So all it does is changes this from 1 and negative 1 to a and negative a, whatever that number is. So what happens if we have y equals sine of b times theta? So I'm going to put b in there now. This is still going to be 90 degrees, 180 degrees, 270, and 360. This will be 1 and negative 1, because I haven't multiplied in front of the sign at all. This one's probably easier to figure out if I just put a number in there. So we're going to start out, let's say it's y equals sine of 2 theta. Now remember, it completes this cycle in 360 degrees. Up here, 360 degrees was one whole cycle, because it was just theta. Down here, however, for whatever value of theta we have, our position on the unit circle is going to be 2 theta. So at 0 degrees, we're still at 0 degrees because 2 times 0 is 0. Sine is the vertical again, so we are 0 units above the axis. So at 0 degrees, we're still at 0. But if theta is 90, 2 times 90 is 180. So we're at 180 degrees on the unit circle. That's over here. Well, that's still vertically 0. So we've got to figure out what happens in between here. Well, to get 90 degrees here, 2 theta equals 90. Dividing by 2, that's going to occur when theta is at 45 degrees. So at 45 degrees, we'll be at 90 on the unit circle. That has a height of 1. As we keep going, to get to the 270 degrees, again, 2 theta equals 270. So that would occur if I divide by 2 at theta equals 135. That's right in here. That's negative 1. And 360, again, that's going to occur at when 2 theta equals 360. So dividing by 2, I get theta is 180 degrees. So at 180 degrees, we've completed a full cycle. And of course, it would keep going just like that. Basically, what this number here does, it can be thought of as one of two ways. B is equal to the number of cycles in 360 degrees. Here that was 2, so there's 2 complete cycles before we hit the 360. Or you can think of as B times theta equals the position on the circle. So if I wanted to look at, let's say, y equals cosine of 3 theta. Now, how many full cycles are there going to be in 360 degrees? 3 full cycles. 1 cycle then will be in, if 3 theta equals 360, dividing by 3 gives me that 1 cycle will be in 120 degrees. So here's 90, that's 135. 120 would be somewhere in here. $240 will be somewhere. So a complete cycle is going to happen between 0 and there. Well, for sine, remember, or for cosine, I should say, we start out at positive 1. And we've got to get back here. We're going to end at positive 1. Halfway in between, we'll be at negative 1. That's at 60 degrees. So at 30 degrees, we'll be at 0. And at 90 degrees, we'll be at 0. And of course, that's going to keep going. I'll make sure I got this right. 120, 240, we'll be back at 240 right there. Here, there we go. There it is. Now what I usually do, once I find out that 1 cycle's in 120 degrees, there are 4 significant points for me on this curve. You know, the starting point, the peak, the zero, the peaks and the zeros basically are your significant points. So I always figure out there's 4 distinct sections. So usually I take a complete cycle and divide it by 4. So once I found out that a complete cycle is 120 degrees, I would divide that by 4 and mark off every 30 degrees. So 30, 60, 90, 120. Those are my significant spots. So sine or cosine starts out at 1, goes to 0, goes to -1, back to 0, back up to 120. Those 4 points tell me where those peaks or zeros have to be. So let's try to combine those two things. Let's say y equals 3 sine 4 theta. First thing this is going to tell us is how far are we going to go up here? 3, and of course down to -3. Exactly. So since that's a 4, yeah, 4 theta equals 360, means a complete cycle is going to be done from 0 to 90 degrees. Sine starts at 0 or 1? 0. So it's going to end at 0. You're going to have a 0 point halfway in between. Peak, valley. So 0 point halfway in between, peak, valley. Does that make sense? Okay. So those are the multiplication ones, the expansions and contractions. We can do the vertical and horizontal dilations of that graph. The next thing we have to worry about is shifts. The simplest shift would be like this. I'll put in the parentheses just to emphasize that +2 is outside of the trig function. All that is doing is instead of centering this curve around 0, it's centering it around +2. So this is 2, so I can draw in my axis there. That's really where the axis of this curve is going to be, is whatever that number is, positive or negative. That's the one that's always at the end, outside of the trig function. Now, technically, it could be written like this. That's the same thing. It's outside the trig function, and it is 2 being added to that trig function. So either
the trig function is always what touches the sine or cosine.
Yes.
Or what is
Inside the sine or cosine. So now, of course, there's nothing else modifying this. So it starts at 2 now. 2 is being treated as 0 here. That's my axis. Goes up 1 at 90, back down to the axis, down 1. So 2 minus 1 would be at 1 at 270, and then back up to 0. I could have y equals cosine of, let's do y equals cosine of 2 theta minus 1. Again, I'm going to emphasize that minus 1 is outside. So what this is telling us is our axis is not going to be at 0, it's going to be at -1. Cosine starts up 1 above the axis. There's nothing multiplying it here. So we're going to start out 1 above the axis. Goes to 0, 1 below, and back to 0. Oops. And back to 1 above. Oh, sorry, you are correct. Yep, I screwed that up. Thanks for catching that. Yeah, it's a 2 theta, so that means there's 2 cycles in 360. So a complete cycle would go to here. There we go. Good catch. So like that. Don't feel bad. I didn't catch it at first either. So I would have missed it if you hadn't said anything. So we can have y equals 2 sine 3 theta minus 2. Where's the axis going to be? -2. How many cycles are there going to be here in 360? 3. So that means one cycle is going to be at 120 degrees. That's going to be somewhere in here. So it actually be 120, so it'll be 30, 60, 90, 120. Sine starts at 0. What's its amplitude going to be? Amplitude is just the height. Instead of going up 1, it's going to go up to 2. So from -2, it goes up to 0, back down to 0, down to -4, back up to 0. Then you can continue it out from there if you wanted to. So it's not so bad once you just see the commonalities of it. Now, probably the most difficult one is if we have something inside the trig function. Let's say if y equals theta plus 90 degrees. Now, yes, I do realize I have to come back and go through these in radians in just a minute. But if we start at y equals sine of theta plus 90 degrees, what that is saying is if we looked at our unit circle, if I put 0 in for theta, it's 0 plus 90. It's going to behave like 90 degrees. If I put in 90 for theta, 90 plus 90 is 180. It's going to behave like 180 degrees. There's a trick that I use to make this simpler for me. And that's this. If I'm doing this on a test or a quiz, I would do this on a scratch piece of paper and draw it out ignoring this. So I've got 90, 180, 270, 360. Of course, my amplitude it's going to go up +1 down to -1. And there is only no shift up or down and only one cycle for 360 degrees. So I'm going to go ahead and draw in my sine curve. 0, 1, 0, -1, 0. So then, if I were to continue with that, and I do have to continue a little ways, 450 here would be the next 90 degrees. It would continue up to 1 again. So now I come back and I look at this 90 degrees. What that is telling me is that this graph starts at 90 degrees. So I'm going to cut it off right there at 90 degrees. So technically, this is my graph right here, from 90 starting over. So I'm just going to resketch that. This is still going to be labeled 0, 90, 180, 270, 360. I'm just shifting everything over. So this is going to become my new 0 point, where 90 degrees was. So that starts out at 1. This is at 0. This is at -1. This is at 0. Then this would be the same as 450. It's easy to remember that this shifts it over 90 degrees. The tough part is remembering what direction it shifts it. So I always just sketch out the graph like as though there was no shift. And that 90 degrees, if it's a +90 degrees, it's telling me it's starting The 0 point has to go where the 90 degrees would be on the standard graph without the shift. So let's say we have, exactly, let's say we have y equals 3 cosine like this. So yeah, I'm going to have to sketch it backwards here. This is going to be 0, 90, 180, 270, 360. I have to go up to a positive 3 and then down to a negative 3. I didn't multiply the theta here because that can cause some issues. So I'm going to sketch out my graph. Like that. Now I'm going to go backwards. I know this is minus 180, which tells me I have to go backwards to at least negative 180. And now my starting point is going to be negative 180. So I'm just going to have to redraw that graph. This is going to be my 0 point. This will be 90, 180, 270, 360. So I'm starting out down here. Simple as that. So now I said I didn't put a number here in front of theta because that number complicates things a bit. If I have y equals sine 2 theta plus 180. When you have both that shift inside here and multiplying the angle, and to be honest, I'm trying to remember right now exactly how that all fits together.
So won't you just do it the same way like you were saying, just ignore the 180? So it'd be 2.
The problem is this is still your equation. This is your full cycle here, right? So you're going to subtract 180. 2 theta equals 180 after you subtract 180. Divide by 2. The end of your cycle comes at 90 degrees. So I'm just going to sketch out my sine curve here. It goes from 0 up to 1, down to 0, down to negative 1, and back up to 0. The end of my curve is at 90 degrees. So this is 90. The beginning of my curve which would normally be 0 degrees, so right here, I have to solve this equation. 2 pi plus 180 equals 0. So I'm going to subtract 180. So 2 pi equals negative, or 2 theta, I should say, equals negative 180. Divide by 2, theta equals negative 90. So this is starting out at negative 90 degrees. So yes, you can see a full cycle is only 180 degrees, but it affects the shift. It doesn't shift the full 180 degrees because this is 2 theta. You can see it only shifted 90 degrees. So now this is still only 180 degrees, so this would be 0 in the middle. This would be negative 45 and positive 45. That's the most confusing part of it. Notice I don't even remember how that multiplication affects the shift. I simply do this. If I want to know, I know that my generic curve looks like this. This would be normally 0 degrees, 90 degrees, 180 degrees, 270, and 360. I know that my standard sine curve, that's what those positions are going to be. So if I have this shift, if I want to figure out what 0 degrees is, I set that equal to 0 degrees and I solve it. That tells me that's negative 90. If I want to know where 360 degrees is going to be after the shift, I set this equal to 360 and I solve it to tell me that that position is at 90 degrees. I could do the same for 180. So this ended up at 0 degrees here. I could do 2 theta plus 180 equals 180. Well, after I subtract 180, I get 2 theta equals 0. Dividing by 2, theta equals 0. So after the shift, what would normally be 180 ends up at 0 degrees. Does that make sense? Okay. So now then, of course, I'm assuming for your class, instead of doing 0, 90, 180, and 270, you're probably talking in terms of radians. So this is still 0. This is pi over 2. This is pi, 3 pi over 2, and then back to 2 pi. Is that what you're using? Okay. I'll be honest with you, I have never been able to get myself to think in terms of radians. I always convert back and forth. But realistically, when you have it this way, the shifts get a little bit simpler. So let's do this as positive 3 and negative 3 here. Let's just throw one out here. Y equals 2 sine 2 theta minus 90 plus 1. So here's the order. This has everything in it. Here's the order I would go through this in. First, I would find my axis. That tells me my axis is at positive 1. So that's my axis. Next, I would find my amplitude. This is telling me my amplitude is 2 above and 2 below the axis. So the top of my curve is going to be there. Bottom of my curve is going to be here. Oops, got the bottom wrong. Yep, it's going to be up 1. Bottom of my curve will be there, 2 below. Next, I know a lot of times I'll do this all together. So I'm going to sketch. This is sine, so normally my curve is going to look like this. So I want to know what is going to be equivalent to the 0. So 2 theta minus 90 equals 0. I would add 90 degrees. So 2 theta equals 90 and divide by 2. Theta equals 45 degrees. So what would normally be 0 on this curve is going to be 45 degrees. Oops, I put in 90 there again, didn't I? I should have put in 90. I should have put in pi over 2. Now, the reason I put in 90 is because when I calculate with it, I would not calculate with 2 pi minus, or 2 theta minus pi over 2 equals 2 pi. I just don't think that way. I always convert pi over 2 to 90 degrees. Actually, should have been 0 here. So if I want to know what's happening at 0, I convert the pi over 2 to 90 degrees. That's going to be equivalent to what's happening at 45 degrees or pi over 4 radians. So this 0 point here is what would normally happen is pi over 4 radians. What would normally happen at 0 is happening at pi over 4. If I want to know where the 360 or the 2 pi is going to be, well, then I have 2 pi or 2 theta minus pi over 2 is 90 degrees equals 360. Adding 90, 2 theta equals 450. Dividing by 2, theta equals 225 degrees. 225 degrees is, what, 5 pi over 4? If I convert it back. So this is what would normally be 5 pi over 4. So you can see that being a 2, the difference between here and here is just pi, or 180 degrees. And you can find each of those points in the middle by doing that. Any questions? Okay. Now, do you have to do just sine and cosine, or do you have to do tangent and any of those?
We haven't touched it, just sine and cosine.
Just sine and cosine. Okay. Yeah, I'm not big about thinking in pi either. I've done the conversions back and forth enough that I'm pretty quick at doing the conversions. So I've always found it easier to convert it to degrees, work with degrees, and then convert it back to radians. Just because my mind thinks it's easier for me to do the conversion than it is to work with the radians for some reason. Now, where the radians become important is when you start dealing with angular velocity. Angular velocity, what they're looking at is if you have something that's going around in a circle, its angular velocity is how fast this angle is changing. As it goes around the circle, of course, that angle is changing position. So angular velocity, which I believe, are you guys using omega as your symbol for angular velocity? Okay. Is your radians times time. Oops, not times, divided by time. So it's in radians per second, radians per hour, per minute, whatever unit of time you're using. So if this is moving in, let's say it is 2 pi radians per second. That is saying every second it is going 1 revolution. That equals 1 revolution per second. Have you guys done conversions between angular velocity and RPMs and all that?
Yeah, we touched it a little bit.
Okay. Your conversions, angular velocity, as we get to the angular velocity, there's 3 that we're going to do. Angular velocity, linear velocity, and then RPMs, revolution per minute. Or sometimes is listed as frequency. The reason angular velocity is so powerful is that if you measure it in radians, angular velocity, of course, is just your theta divided by time, radians divided by time. Angular velocity, or linear velocity, then, is just your angular velocity times your radius. So if I have something that is going at pi over 2 radians per second, if it has a radius of 3 units, the linear velocity is pi over 2 radians per second times 3 units. So it's going to be 3 pi over 2 units per second. So if that's 3 inches, that's going to be inches per second. If that's 3 feet, it's going to be feet per second. RPMs let's say we've got, well, let's stick with the pi over 2 radians per second. What we have to do with that is this. That's going to be pi over 2 radians over 1 second. We have to convert radians to revolutions. We know that 1 revolution equals how many radians? 2 pi. So I'm going to put radians down here, 2 pi radians, and 1 revolution on top. So now the radians will cancel out. Pi's will actually cancel out, so this is going to be 1/2. And this will just be 2. And then I have to convert my seconds to minutes. 1 minute is 60 seconds. So my seconds cancel out. So I have 1/2 times 1 times 60 is 30 revolutions. On bottom, I have 1 times 2 times 1 minute is 2 minutes. So that is 15 revolutions per minute. So it's just a measurement conversion is all it is. Okay, we're about out of time. Is there anything that you guys have any specific questions on today that you want me to go back over quick in our last couple minutes?
No, that was. Actually, I just have one question on. I think it was 2 equations up. And
this one? Next one up?
more.
This one?
That one right there.
Okay.
For that one, isn't the +2 made that shifted up 2?
Yeah, I never did do the +2, did I? Yeah, this technically this axis would not be at 0. This would be at 2 here. And,
Okay. I just wanted to double check that.
yep, you're correct. I should have. So then technically this up here would be 5, and this down here would be -1. So it's got an amplitude of 3. Yeah, good catch. Any other questions? Okay, do you guys want to meet on Wednesday again?
Well, because I think we have a test in math on Wednesday.
Is it Wednesday afternoon?
Yeah, it'd be a couple hours after this session.
Okay. So we'll plan on meeting Wednesday and probably cancel Friday. If you got a test coming up, you won't have anything new that soon. Okay, so I will pass that word along.
All right.
Okay, you guys have a great day.